All right. On your review, number 14, we're going to do B and D together. We're going to do part B and part D. Is B an exponential or a logarithmic form equation? Exponential. How do you know just by looking at it? It has an E. What else? What does it not have?
A log.
It does not have a log. This is in exponential form. When we have an equation that is in exponential form and we are supposed to solve it, first step is to isolate the base with the exponent. Yep. Can you please have what? Yep. We need to isolate the base with the exponent. So in this problem, in part B, what is the thing that has an exponent on it? Close. The E. E is the thing that has an exponent on it. So this is the thing that we need to isolate. We're going to isolate the E that has the exponent on it. We have to use order of operations in order to do that. And when we are isolating something, we go backwards through the order of operations. So that means we have to start off by undoing any addition or subtraction that we see. Over here on the same side where the E is there any addition or subtraction that we're going to need to undo? Yes, what is there? 7. How do I make it cancel? Add 7 to both sides. All right, so I have 2e to the negative 4x equals what? 16. Have I isolated the base that has an exponent on it yet? No. This is the thing that I need to isolate. How do I do that? We're going to divide it by 2, yes. This 2 is being multiplied, so I need to divide it on both sides.
And you get exponent of negative 4x equals 8.
E to the negative 4x equals 8. Absolutely. All right, so we did this. We did this. So we have now isolated. Once we've isolated the base that has the exponent on it, now we want to rewrite it in log form. We're going to rewrite this into log form. So if I'm going to rewrite this in log form, what do I have to start it with? Log. L-O-G. What would come after the G? The E, the base. My base comes next. What comes after the base? The 8, the argument comes next. And then equals what? Negative 4x. The exponent comes down here. Don't we have another way of writing log base E? Close. It's not IN, it's LN. It looks like a capital I, but it's an LN. So this is LN of 8 equals negative 4x. What would I need to do now to get the x all by itself?
So since it's log e, is another way for log e is ln e.
Yep.
Which you divide it by negative.
Divide both sides by -4. All right, so depending on how the problem says you're supposed to give the answer, if it wants an exact solution, that's what we've just found. Before you even put it into your calculator, x equals the natural log of 8 divided by -4. That would be the exact solution. For the approximate solution, you have to type this into your calculator. If you don't have a yellow calculator anywhere near you, please come and grab one from the front. What's in the blue square? You're not going to put the x equals part, but you're going to put the fraction. You're going to push the ln button, not second, just ln, and then you're going to put an 8 inside the parentheses that open up there, and then down on the bottom you're going to put -4, and then you'll hit enter. Yes.
You divide it, you don't put it on the fraction, right?
Did you push -4 or -4?
So it's 0, it's 0, it's 0, it's
-0 point.
Negative 0.5198.
-0.5198, or you could round that to -0.52. You put a 3 instead of an 8. Other than that, you typed it in absolutely correctly. All right. How we doing?
Well, I put negative 0.5.
That's fine. -0.52 is fine. Precious read it off with 4 decimal places, so I wrote it down with 4. If you round it to -0.52, that's totally fine.
Wait, so the PE in the AS, that goes with log, right?
PEMDAS. We use PEMDAS anytime we are isolating or solving. Yes.
When I looked up the
It says 5.1.
it says 0.51. It
Yeah.
doesn't say negative. It just says 0.
Ah, I will make sure that it says negative. It should be negative.
Don't say that because I did it. You did. No, I didn't.
All right.
You said when isolated.
Whenever you're isolating or solving. Whenever you isolate or solve. All right. Part D. What form is Part D written in? Exponential form or log form? Yes, this is in log form. The one up above was exponential form. It's something with an exponent on it. This one's log form because it says log. All right, so the first thing we have to do, again, we're going to be isolating. We have to isolate the log with the argument. So what is the argument? What is the argument? Nope. Nope.
Is it? Oh, is the argument the A? Can I pick up?
So we have log base argument equals exponent. 6x plus 2. So this right here is what we need to isolate. How are we going to isolate log base 2 of 6x plus 2? What do we need to get rid of?
Wait, I mean log base 2.
That's what I need to isolate. 72 is on the other side of the equal sign. It's the log base 2 of 6x plus 2 that I need to isolate. I need that to be the only thing on that side of the equal sign.
Get rid of 8.
Get rid of the 8. What operation is connecting the 8 to the log? Multiplication. So how are we going to make it cancel out? Division. We're going to divide both sides by 8. That'll make my 8s cancel here. So on the left, I'm still going to have log base 2 of 6x plus 2 equals what? 9. Have I isolated the log with its argument?
Wait, why is it,
Is it logs switched on like a 6?
Not necessarily. That's one of the bases. A log can have a base of anything that's positive. We said that the log with its argument is what we have inside this red box here.
So was the argument 8?
No.
What was the argument?
Look, argument is right here.
Oh, yes.
Have I isolated the log with its argument?
No.
oh wait, you still got the 8.
Where's the 8? It's not there anymore. We have isolated it. I need the log and I need the argument still there. So this is isolated. Nope. So once we've isolated the log with its argument, back up here in exponential form, do you remember how we had to rewrite it into log form? For this one, we're going to rewrite it into exponential form.
In exponential form is like L and
All right, let's write this down. Guys, I need the side conversations to stop. They're very distracting and they make it difficult for me to hear. We're going to rewrite this in exponential form. So exponential form starts with your base, then it has the exponent, and that will be equal to the argument. So what is the base on this log? What is the base on the log? 2. So we start with that. What is the exponent for this? 9. And that is going to be equal to what? 6x plus 2. So all of this. Not yet. I need you to put this part in your calculator. What is 2 to the 9th power? 512. Now we can subtract 2 from both sides. So I'm going to minus 2 from either side. What is 512 minus 2? 510 equals 6x. What do I still need to do? Divide both sides by 6. What is 510 divided by 6? X equals 85. If you struggled with solving either one of these, I would make sure to have the directions for how to do that written down somewhere on your cheat sheet, or to have an example problem worked out with arrows showing where things are going and how you're getting it that way. Yes, ma'am. Yes, I do. There you go. You're welcome.
Wait, what's the B? Oh, wait, base?
That's just showing how you go back and forth between the two forms. That's your base. Yes. No. It's got the negative, sweetie. It has the negative there. I changed that to a 2, but it has the negative there on the answer sheet. Go back and look at it one more time.
So can it still be 0.51?
If you put negative 0.51, I would count that as correct. Do you guys have any questions on either one of these? All right. Let's talk expanding and condensing. Yes, there is nothing on the review that we did not cover in class. All right.
My thing is, the only thing I remember is that you could take the 2 and you put it behind the.
Yes. We're going to do part A on number 15. We're going to do part B on number 16. You guys will have the others to practice on your own. When we are condensing, we do the powers property first. Powers, product, and quotient are the properties. Powers, product, and quotient. So when we're condensing, we do powers first. That means I'm looking for any numbers that are in front of logs, any coefficients like this 2 right here. Do you guys see any other coefficients, any other numbers in front of logs? 3 and 4. We're getting ready to write them down. Huh? So these numbers are going to come back and be exponents on the arguments.
Yes, but that's the power, right? It's numbers in front of logs.
Numbers in front of logs, yes. So log base 3 of x squared plus log base 3 of y cubed minus log base 3 of z to the 4th.
Oh, wait, you mentioned x.
Yes. The numbers out in front, the coefficients out in front will become exponents. They'll become powers on the argument right behind it. Powers are exponents, yes. Then we do the product property. With the product property, you look for addition. Do you see any addition between logs?
Oh, is that when
Yes.
you multiply when you see addition and subtract when it's like?
Yep. So when you see addition, you're going to need to use the product property. You take the arguments of the logs right before and after the plus sign. So I'm going to take the x squared, and I'm going to take the y cubed. These two pieces are going to be multiplied.
And this is just for,
Is it after a plus sign? Then we're not dealing with that yet. We'll deal with that in a minute.
and this is just for x, like when you condense it.
This is when we're condensing.
Only for condensing.
Yep.
That says product what?
Product, look for plus.
Oh, okay.
When we condense it down together, when I find these pieces, it's not going to have 2 logs anymore. It's going to condense down to just 1 log. So log base 3, and I'm going to multiply the x squared and the y cubed together because they have a plus sign in between them. So we're multiplying those 2 things. And then I'm going to bring down the minus log base 3 of z to the 4th, because we haven't done anything with that yet.
Wait, so why don't why isn't the base 9?
Because the base is 3. The base doesn't change all throughout this. Whatever the base is, it's that same base all the way through. All right, we've talked powers property. We've talked product property. Now we're going to talk quotient. With the quotient property, now I'm looking for subtraction. Do you see subtraction between logs? Yes. So I'm going to take the argument in front of it. That's going to become the top part of my fraction. The argument after it will be the bottom part of my fraction. It's going to condense down to just 1 log. You will not have 2 logs anymore. Log base 3. Yep.
Oh, is it x cubed
Yep, x squared y cubed
over 7. That's Z.
over z to the 4th power.
Wait, why can't they do the fraction?
Because you saw subtraction.
Okay.
When you see subtraction, it turns into division. If you see subtraction, write a fraction. All right.
And then we just ignore the other 3 and the log and the line.
What'd you say?
We just ignore the other 3 and the log.
We're not ignoring it, we're condensing it.
What if they were 2 and the numbers? Would that ever
Like if it was a log base 3 and a log base 7, we couldn't do anything with that. That's our final answer. Oh, gosh. All right. There we go. All right. Let's do number 16, part B. Before we do that, though, I do want to mention that if you go to look for your powers step and there are no numbers in front of the logs, then you skip that step and you move on to the next one. If you don't see any addition between logs, then you skip that step and you go to the next one. And if you don't see any subtraction, then whatever you got back here would be your final answer. Yes?
So we're not doing A, but so for A, you would skip power because it doesn't have any power. And then
For number 16, we're going to do a different process. We're going to expand. Number 16, we're expanding.
so you're making it bad for that. So basically on B, B would do the power, put it back, and then you do the product. Since it's an addition, you would multiply them together, and then it would just stay at that because there's no subtraction.
That's exactly right.
So then for 16, you're going back.
For 16, we're going backwards. So I'm going to do everything in reverse.
How do you spell
Quotient. Q-U-O-T-I-E-N-T. And that's where we're going to start. When we did our quotient step back here, we were looking for subtraction, and it turned into what?
A log. Oh, a fraction.
Fraction. We looked for subtraction, and it turned into a fraction. When I'm going backwards, I'm going to look for
Subtraction.
look for division, and it will turn into subtraction. So now we're looking for division. Is there any division in my argument? Yes. Right here is my division. When I'm expanding, everybody gets logs. So I'm going to have ln of my numerator and ln of my denominator. So ln 3x squared. Instead of division, the fraction turns into subtraction. Minus ln of y cubed. Everything happens in reverse. So quotient, look for a fraction, turn it to subtraction. Then we're going to do our product step. I'm going backwards. Here I was looking for plus, and it turned into what? Multiplication. So now I'm looking for multiplication, and it will turn into a plus. So look for multiplication. Is there any multiplication in either one of these arguments? The 3 and the x is multiplying. So the ln is not being multiplied to y. ln is its own operation that's happening to the y. So ln is going to distribute here. This isn't really distributing, but you can think of it like that. Each of these is going to get their own ln, their own log. So natural log of 3. Yep, natural log of x squared. What do I put in between those two? Addition. I bring down minus ln y cubed. Everything in reverse. You're welcome. What's the last step I need to do then? Powers. When we were condensing, I was looking for numbers, coefficients in front of logs, and they were becoming exponents. So I want to go backwards. What am I looking for here now? I'm looking for exponents. Does this first argument have an exponent?
Yes.
No. The 3 does not have an exponent on it. What about here? That one has an exponent. So this 2 comes in front of this middle ln. Nothing comes in front of the first one. Are there any other exponents? The 3 on the y. So that goes in front of the ln after the minus sign. ln 3 just comes straight down. Plus 2 ln x minus 3 ln y. That is our final answer. One thing that I definitely want to make sure that you guys understand before we move on to anything else. If you write log or ln, you have to have either a number or a variable right after it. You can't have ln plus. That doesn't make any sense. That would be like me coming up to you and being like, 4 plus, what's the answer? And you're like, 4 plus what? You have to have either a number or a variable after an ln or after a log. If there is no number or variable after your ln or after your log, it's not going to be correct. It has to have an argument there. Do you guys have any questions about either 15 or 16?
You said letter after?
It has to have, after you write log or ln, you either have to have a number right after it, or you have to have a variable right after it. I want to do one more log problem with you guys, and then we'll start talking about some rational stuff. Right? We're going to do 17b. We're going to have to, it's in the logs section, but no, we're not going to use logs for this. But it's in the logs section because that's where we talked about it in our curriculum. Right. 17b.
So this is not a log.
We're not going to have to use logs to solve this, no. First thing I look at here, I need these bases to be the same. Are these the same right now? Not the same.
So you have to like make it like. So when you do this, you have to like to make them to the things the same. Since it's the 5 is already this, it has to be 5. Whatever multiplies 5 to get that number.
Sort of, yes. Is there a way that I could rewrite this base of 5?
But you can do the 125.
I can rewrite 125 because 5, that's what, 5 times 1 or 5 to the first power. Like that's the only things that work for 5. So I can't mess with that one. What about 125?
You do 5. Is it 5 to the power of 5?
Close.
5 to the power of 3.
5 to the power of 3. This is exactly the same as 5 to the power of 3.
So you just like you just basically whatever the base is for the other one, you just multiply that to see what gets the
Yep.
other number.
All right, so I'm going to rewrite this then. I have 5 to the power of 2x. I couldn't do anything with that. On the other side, though, instead of writing 125, I'm going to write that as 5 to the 3rd power. But then this had an exponent on it already, right? The exponent has to come down to the outside of this, x minus 9. I need to take this exponent of 3 and distribute it to both of those pieces.
So 5 is plus 2x equals 5. X exponent 3x minus
3x minus
27.
27, yes. Are my bases the same now? Yes. If these bases are the same, then that means the exponents have to be equal. So 2x equals 3x minus 27. And then we're going to solve that for x. If I'm going to solve this for x, I need my x's on the same side. How do I get my x's on the same side?
Subtract 3.
I think it's 27.
3 times negative 9. We're going to subtract 3x from both sides. What is 2x minus 3x? Negative 1x. Give me just 1 second and I'll get there. I'll back up, I promise. Bring down this minus 27. Don't forget to bring that minus down with it. Do I have the x totally isolated?
Yes. No.
No.
You have to divide by negative 1.
Divide by negative 1 on both sides.
8 equals negative 27. No, 8, x, I mean.
X equals, I have negative 27 divided by negative 1. Negative 27 divided by negative 1. Positive 27. All right, questions?
Oh, okay. With the 2x and the arrow, what did it do?
Right here,
Yeah.
all I did was, see how these bases are exactly the same, they match? Then that means the exponents on either side of the equal sign have to be equal. So the 2x came down, the 3x minus 27 came down, and the equal sign between them came down.
So because they're equal?
They are equal. Once your bases are the same, the exponents are equal to each other.
So the 5s, like, once they're the same, they're just...
They basically cancel.
Okay.
Once your bases are the same on either side, they basically cancel out. All right. Do you guys have any questions at all about this problem? Okay. Yes, sir.
Condensing its powers product
Condensing powers product quotient.
quotient. Expand its product,
No.
quotient product power.
Yes, you go backwards. Powers product quotient, quotient product powers.
Okay, so what do we do if our exponents are
If your exponents are already what? You need the bases to be equal. If the bases are equal, that automatically means the exponents are equal.
But we have to check it, right?
This we don't have to check.
So on our exam, we don't have to check it.
On a problem like this, you do not have to check. If it is a log problem, you do need to check on log problems. And all you need to check to make sure is that that argument isn't a negative number and it isn't 0.
So as long as the argument is a negative 0, it's right?
Yep. As long as the argument is not a negative or a 0, you have an answer that is hopefully correct.
So to check the log argument
Argument has to be bigger than 0.
and positive?
That's, yeah, it has to be bigger than 0. Not equal to, has to be bigger than. Any other questions at all about logs? All right. Let's switch gears and talk about rationals then. I want to do number 19 first, because number 19 is just a factoring problem. What do we always look for first if we are going to factor something? Greatest common factor. So first, you always have to check for and get rid of a GCF. Second, you would make your area model and your X. So on number 19, is there a GCF? What does the G in GCF stand for? Greatest common factor. So I need the biggest number that will go into all three of those. 4. Be careful when you're pulling out a GCF. 2 goes into each of those things too, but the G in GCF means greatest, biggest. I need the biggest number that goes into all of them. So I'm going to divide them all by 4. You cannot throw away the GCF. What does the F in GCF stand for? Factor. We are supposed to factor this, so that is part of my final answer. All right, so I have 4 that gets factored out of each piece. That leaves me with x squared minus 6x plus 9. This right here is all I use for my area model and my x, my box and my x. The 4 is part of my final answer, but I don't use it for my box or my x. So I'm going to draw my box, my area model, and I'm going to draw my x. I need A and C here, A times C and B. So I put x squared here and 9 here. I have 1x squared and a positive 9. What is 1 times 9? 9. I need 2 numbers that multiply together to give me 9, but add together to give me what? Close. Negative 6. Negative 3 times negative 3. So negative 3x and negative 3x. What can I take out of x squared and negative 3x? What goes into both of those? X. What can I take out of negative 3x and 9? What goes into both of those? 3. Positive or negative 3? Why negative? Because it's touching a box right here that's a negative. All right, let's do columns. X squared, negative 3x. Just an x. Negative 3x and 9? Negative 3. So I got 2 of the same thing. So factored form, don't forget the 4. That is a factor. X minus 3 is a factor, and the other x minus 3 is a factor. Yes, you can. Your answer can look like this, or since x minus 3 is the same as x minus 3, you could write x minus 3 squared. But you have to have the 4 out in front there. Yes. Yep. We're going to do 18 first, then we'll come down and we'll do one of the ones in 21. I'll let you guys choose. Number 18. What do you notice about number 18? It's a fraction. It says we are supposed to simplify. If I am supposed to simplify one fraction, that means I'm going to reduce it. If there's just one fraction and it says simplify, then we're going to reduce that fraction. We'll talk about when we have 2 fractions. So if I'm going to reduce this, I need to see if there's any factors in common that will cancel out. We're going to factor the numerator. We're going to factor the denominator. What do we always look for first if we're going to factor? GCF. Does the numerator have a GCF? No GCF. All right, so I'm going to come over here, see 3x squared minus 5x minus 2. No GCF to take out, so straight on to area model and x. So A and C, A times C and B. 3x squared, negative 2. So 3x squared times negative 2. What is 3 times negative 2? Close. Negative 6. I need 2 numbers that multiply to negative 6, but add up to what? Negative 5. What are some things you know of that multiply to 6? 3 and 2. 6 and 1. B is a negative number, right? So in each of these pairs of numbers, the bigger one would have to be the negative one. -3 plus 2, -6 plus 1. Which one of those gives me -5? -6 and +1. So those are the numbers that I'm looking for. So -6x, +1x. All right, rows and columns. 3x I can take out of both of those top two boxes. What about 1x and -2? 1, positive or negative 1? Positive, so 3x plus 1 is a factor of my numerator. What about 3x squared and 1x? 1x. Be careful on this next one. -6x and -2, the biggest thing that'll go into both of them. -2. So this numerator factors to be x minus 2 times 3x plus 1. Yes, you can put a 1 there. Then we go to factor the denominator. Does the denominator have a GCF? No GCF. Does anybody notice anything special or interesting? It doesn't have a B term. That means this is a special type. What do we call this type if there is no B? Does anybody remember what we call that? Does anybody remember what we call it when there is no B value? Starts with a D. Difference of perfect squares. This is a difference. If you don't know that, that would be very helpful, yes. Difference of perfect squares. When we factor a difference of perfect squares, how many factors do we get? 2. What will be the only difference between them? Yep, one's going to be a minus, one's going to be a plus. Then I look at each of the terms. First term is 9x squared. What multiplied by itself would give me 9x squared? 3x. So each of these factors has a 3x in the beginning. And then I look at the last term, 1. What times itself gives me 1? 1. So 3x minus 1, 3x plus 1. Can I reduce this fraction at all? Are there any common factors between the top and the bottom? 3x plus 1. So what I have left over is x minus 2 over 3x minus 1.
So the 9x, that's where the came from, because you put them together to be honest.
3x times 3x gives you 9x squared, yes. For a difference of perfect squares, you're always saying what times itself gives me that piece. And then each factor gets one of those. I am going to skip number 20 because we have to practice that exact same skill in number 22, and that's one that I want to do with you guys.
Why should you make it a plus to a regular second?
When you have a difference of perfect squares, one is plus, one is minus. Because, look at that last term. See how it has the minus 1 on the end? To get a minus 1, I have to take a positive 1 times a negative 1. If they were both negative, what's negative 1 times negative 1? Negative times negative is positive, so that would be a plus sign there instead of a minus. We're going to skip number 20 because the skills that we use in number 20, we're going to have to practice again in 22. And I want to do all of 22 with you.
How do we know if when we put into that the division stuff?
Huh?
How do we know when we need to put into division stuff? Like long division, yeah.
How do you know when you need to do long division? If there's no x squareds, but you still have an x on top and an x on bottom.
Okay, so
No more x squareds, but you have an x on top and x on bottom. We'll get there. She's on a different problem. I do want to look at number 21. I want to do one of the parts with you. Do you guys want to do part A or part B on number 21? You want to do A. Honestly, A is harder than B. Let's do A. The directions here also say simplify, but now I have two fractions. Kaylin, this is what you're asking about. Directions say simplify, but I have two fractions. There's something that I notice about this problem. There is no equal sign. When there is no equal sign, that means you will not be able to cancel things. No equal sign means no canceling. If I'm going to add or subtract fractions together, I have to have what? If I'm going to add or subtract fractions together, what do I have to have? I need to have a common denominator. You're close. LCD means least common denominator. So it has that common denominator in there. We need a common denominator. The bottoms have to be the same, yes. Are these denominators the same? Do they have any factors in common? Probably. I would need to factor these to see if they have anything in common already. Can I factor x plus 2? No. This one I can factor. Over here, there's no GCF. There's no x squared. So we do not factor it. The other one, we are going to try to factor. Does this one have a GCF? No GCF, but it does have an x squared. So I'm going to do my area model and my x. If you guys don't know how to factor by the end of Algebra 2, I have not done my job. What we're doing right here. You have to be able to factor. All right, so I have x squared and negative 12. So 1x squared times negative 12. Two numbers that multiply together to give me negative 12, but add to what? Negative 4. What are some numbers that you know of that will multiply to 12? 4 and 3, 6 and 2, 12 and 1. Is B a positive or a negative number? B is a negative, so the bigger number in each pair would have to be a negative. Which one of these pairs, when I add them together, gives me negative 4? Negative 6 and 2. So negative 6, positive 2, negative 6x, positive 2x. What's the GCF? What's the biggest thing I can take out of x squared and negative 6x? I can take an x out. What about 2x and negative 12? 2, positive or negative 2? Positive. X squared and 2x, x. Negative 6x and negative 12, negative 6. All right, so I'm going to rewrite these two fractions. X over x plus 2, I can't change at all. Minus x plus 4 up on top. Down on the bottom, I have x minus 6 and x plus 2. Do these denominators have anything in common already? They have an x plus 2 in common. The second denominator has something that the first one doesn't. So that means I have to multiply top and bottom by x minus 6. So I have to take this x and distribute it to both of these pieces. So that gives me x squared minus 6x. Do you see this minus sign right here? The minus sign has to distribute to everything behind it. So minus x and minus 4. Why didn't I do that to where? We only distribute to the numerator. This x distributes here. The minus sign only distributes behind it. Over my common denominator of x minus 6 and x plus 2. We are almost done. Are there any like terms that I should combine? Which pieces are like terms? Negative 6x and negative x. These are like terms, so I need to combine them together. So I have x squared. What's negative 6x minus another x? I have negative 6 minus one more. Negative 7. Negative 7x minus 4 all over x minus 6, x plus 2. Tomorrow, we will start with number 22. Give me just 1 second here. Guys, tomorrow is my last day to study with you. Tomorrow is my last day to study with you because your final exam is Monday. We will not have study time during D lunch. You will be taking your exam. That's how you get the full amount of time for the final exam. Give me just 1 second.
Can I give this to me?
You can give it to me and I'll take it over
Thank
to her.
you.
You're welcome. Final exam has how many parts to it? 2 parts. What are those 2 parts? Multiple choice. And the short answer, yes. Which part will you do first? Do the short answer part first. That's what I'm going to hand you first. It's the part on paper. How do you complete the multiple choice part? On the computer. You have to bring your Chromebook, bring your chargers too, so that you can do the multiple choice on Canvas. I will not have printed copies, so you have to bring a device with you. There will not be any printed copies of the multiple choice. Tomorrow we're going to start off with number 22. Then we're going to come over and we're going to do one of the problems in number 23, your choice. We'll do number 25, and then we'll do a graphing problem. After that, if we have time, I'll review some of the probability and statistics stuff, but I'm not as concerned about that because that's the test that you guys just took, and for the most part, we rocked that one. All right? I am happy to answer any questions that you guys still have about this. Answer key is posted in Canvas already. Please let me know if you have any questions.